Number 13. We are asked to draw this graph. So we have our function. Okay, so these sketching a graph, there's a lot to that. So these are not just, short little multiple choice questions. This was like a whole page of the test when we did that, and that's going to be the case on your final. You'll have one of these, and that's the only question on that page, going through all this stuff. So it's a lot of points. It's not a question to just say, oh well, I'll wing it. You should make sure you know what you're doing. So vertical, horizontal asymptotes. Vertical asymptotes are x equals whatever makes the bottom 0. So I want to know, when does x squared plus 4 equal 0? So that means x squared equals -4. And if you do the square root of a negative, what do you get? Imaginary. So there is none. So vertical asymptote, none. Horizontal asymptote, we have to do the limit as x approaches positive and negative infinity of x squared minus 4 over x squared plus 4. So if I just plug in right now, I have infinity over infinity, and we can't solve that. But the trick we often used was to divide everything by the highest power of x. So x squared over x squared is 1, minus 4 over x squared, over 1 plus 4 over x squared. So then you get 1 minus 4 over infinity goes to 0 over 1 plus 0, which is just 1. So the horizontal asymptote is y equals 1. And when you find all this stuff, I'm expecting it to be plotted on your graph. We don't find it just for fun. That's how we're getting the graph of our function. So at y equals 1, you draw in that asymptote. All right, next thing I asked for, critical points. What are critical points? We're in trouble. What's a critical point? How do I find them? So, my derivative. This is a fraction, so we have to do quotient rule. So low, d high, derivative at the top is 2x, minus high, d low, over low, squared. Alright, so this gives me 2x cubed plus 8x minus 2x cubed minus 8x. Um, 2x cubed negative 2x cubed will cancel. 8x and 8x gives me a 16x over 6. So that's my first derivative. So critical points are anywhere this thing is 0 or undefined. We've already figured out it's not undefined anywhere because we didn't have any vertical asymptotes. When does that equal 0? At 0. If you set the fraction equal to 0, you get 16x equals 0. So x equals 0. All right, then I asked you increasing and decreasing. So we made the sign line. So we started 0, you have to plug in something smaller and bigger. So if I put in something smaller, I get a negative over a positive, which is negative. Put in something bigger, positive over positive is positive. Please stop me if I lose you anywhere. So this function is decreasing from negative infinity to 0 and increasing from 0 to 1. We also know the max and min from this.
0 to 1.
0 to infinity. We know if you are decreasing and switch to increasing, is that a maximum or a minimum? Minimum. So we have a local min at 0, comma. We need the y value to plot the point on the graph. So if you go back to the original, if you plug in a 0, you get -4 over 4, which is -1. So 0, -1 is the minimum on our graph. Alright, so we did the increasing, decreasing, we did max and min. Now we need inflection points. How do we get inflection points? Second derivative. Alright. So second derivative, we still have a quotient. So it's low, d high, derivative of the top is 16, minus high, d low. So the 2 would come down, inside stays the same, subtract 1 from the power, so it's to the first, times derivative of the inside, which is a 2x, over low squared. So it was squared, so if I square it again, it becomes to the 4th. Alright, all of these have an x squared plus 4, so we can cancel one of those out. So we have 16 times x squared plus 4, so 16x squared plus 64, minus 16x times 2 times 2x, so that would be 64x squared over the denominator. Alright, so then we get negative 48x squared plus 64 over the denominator. So inflection points is where this is 0 or undefined. It's undefined when the bottom is 0, which we've already established can't happen. If we figure out when the top is 0, so if we divide by the 48, square root plus and minus would be 2 radical 3 over 3. So those are the inflection points. We are trying to find our concavity. So we make our sign. We have negative 2 radical 3 over 3, positive 2 radical 3 over 3. Alright, so something in the middle, something bigger, and something smaller. Put a negative 2 in, you would get a negative over a positive, which is negative. Then 0 positive over positive is positive, 2 negative over positive is negative. So we are concave down from negative infinity to negative 2 radical 3 over 3, and from positive 2 radical 3 over 3 to infinity. We are concave up in between those. You have to be able to mark those inflection points on the graph, so we really need to get actual order pairs for them. So if you plug those into the original, if you put 2 radical 3 over 3 in to the original, grab a calculator, do that for us. So negative 1/2. We're putting the 2 radical 3 over 3 into the original. Is that what you guys think? Anybody have an answer for me? Huh? 2? What'd you get? Okay, I was right. Woohoo.
For the negative.
And you're going to get the same thing when you put in both of them. Okay. So we are going to approximate those on the graph. That's like a little over. Okay. So remember we usually marked inflection points with an X. So those are my 2 inflection points. So then we sketch our graph. We know we are decreasing until we get to this point. Until I get to my X, I have to be curved downward. And we also have to be approaching our asymptote. So decreasing, curved downward. I need to still be decreasing, but now I'm curving upward. The graph is not great. Curving upward. Now we're curving back downward. So it looks something like this. All right. Let's look at 15, if you guys are good with that one. 15b. We have the limit as x approaches 0 from the right of x natural log of x. So this is currently 0 times negative infinity. That's an indeterminate form. We can't do that. If we can get 0 over 0 or infinity over infinity, then we can use L'Hopital's rule. So our strategy was to move one of these things to the bottom by dividing by its reciprocal. Now I would rather not have the reciprocal of a natural log, so what I'm going to do is move the reciprocal of x to the bottom. So that's 1 over x. Okay, or you can think of this as natural log of x over x to the negative 1. So, natural log of 0, that's going to negative infinity. 1 over 0 is going to infinity. This is infinity over infinity. That's an indeterminate form. So we can do L'Hopital's. So L'Hopital says we can simplify this by doing derivative of the top over derivative of the bottom. Not the quotient rule, just their separate derivatives. The derivative of a natural log x is 1 over x. The derivative of x to the negative 1 would be negative x to the negative 2. Always try to simplify this to see if it's ready to reduce. Negative x to the negative 2, that's like negative 1 over x squared. How do you divide by fractions? Multiply by the reciprocal. So we get the limit as x approaches 0 from the right of negative x, which is just 0. C. And with the limit x approaches 0 from the right of x squared. So this is currently 0 to the 0 power, which we cannot simplify. We're trying to get 0 over 0 or infinity over infinity. There's no way to easily write this as a fraction. So if you remember, what we did was we added a log to this. Now what's the opposite of a log? E. So we have to undo this at some point, so at the end our final answer will be e to whatever power we get. So we'll add the e at the end to cancel this. The reason we like this log is because properties of logs allow you to bring down the square root of x. Then we can do it like the previous problem, where we turn it into a quotient. So we have the natural log of x over 1 over the square root of x, or you could write it as x to the negative 1/2. So this is currently infinity over infinity. That's an indeterminate form. It's now ready to do L'Hopital's. So the derivative of the natural log is 1 over x. Derivative of x to the negative 1/2 will be negative 1/2 x to the negative 3/2. So if you're trying to simplify this, we can flip and multiply. We have x's on top and bottom, we subtract their exponents. So we get negative 2x to the 1/2. So 1/2 power is the square root, so negative 2 times the square root of 0 is just 0. So my final answer is e to the 0 power, which is 1. Is that okay with everybody? So number 16. This is another one of those graphing questions. So this time our function is 1 plus 1 over x squared. All right, so first question I asked you is the domain. What can x not be? 0, so my domain is everything else. Negative infinity to 0, union 0 to infinity. X and y intercepts. X-intercept is when y equals 0. So if I plug in a 0 for my y, if you multiply the thing by x squared, we can't do box method. If you try quadratic formula, what do you get under the radical? You get 1 minus 4, which is a negative, so it's imaginary. So is there an x-intercept? No. Y-intercept is when you plug in 0 for all of your x's. Can I make x equal 0? No, so there's no y-intercept either. C, I want you to skip dissymmetry. We actually glossed over that, and I forgot that when I was writing that question on your study guide. So forgive me there. D, vertical and horizontal asymptotes. So we've done this already. Vertical is x equals whatever makes the bottom 0, so that would be x equals 0. Horizontal, you have to do the limit as x approaches positive and negative infinity. So we get 1 plus 0 plus 0, which is, thank you. Yep. So our horizontal is y equals 1. Then it asks you for increasing and decreasing. How do we find where things are increasing and decreasing? We've got to do the first derivative. Okay, so my first derivative. Derivative of 1 is 0. 1 over the x, that's like x to the negative 1, so it'd be negative x to the negative 2. 1 over x squared, that's x to the negative 2, so minus 2x to the negative 3. We're trying to figure out where this is 0 or undefined. So where is it undefined? Can you tell me that? At 0. So we already know we're going to have a critical point when x is 0. Let's figure out when this thing equals 0. So we could add over one of them, cross multiply. If you divide by x squared, you get x to be negative 2. So my critical points are 0 and negative 2. So then we do our sign line. So smaller than negative 2, maybe negative 3, in between, and bigger. We're putting these into the derivative. So I put them in right here. Negative 3, that would give me a negative 1/9 plus 2 over 27, so that would be a negative. Put in negative 1, I get negative 1 plus 2, so that's positive. Put in 1, negative 1 minus 2 is negative. So we are decreasing negative infinity to negative 2 and 0 to infinity. Increasing negative 2 to 0. Then I ask you about max and min. If you go decreasing to increasing, what is that? A min. So we have a min at negative 2. Plug negative 2 into the original. So 1 minus 1/2 plus 1/4, so that would be 3/4. Here we went from increasing to decreasing, which would tell me max, but can you plug 0 into the original? No, so there is no max. Then I asked you for concavity and inflection points, so we need second derivative. So if I just do this derivative from here, we get 2x to the negative 3 plus 6x to the negative 4. You could write that as 2 over x cubed plus 6 over x to the 4th. So my inflection points, we have to worry about when it's undefined, which is when x is 0. We have to also figure out when this thing equals 0. So if you cross multiply, divide by, let's divide by 2x cubed. So that'll give me an x equals negative 3. So test points, plugging those in. So if I put in a negative 4, I get 2 over negative 64, 6. 256, so negative. Negative 1 should give me a positive, and 1 should give me a positive. So we're concave down from negative infinity to negative 3. Can I just say I'm concave up from negative 3? Why not? Yeah, at 0 we had an asymptote, so you do have to break that up. The actual inflection point that we would mark on the graph, negative 3, comma, if you plug negative 3 into the original, we get 1 minus 1/3, so 2/3 plus 9, so 7/9. All right, so now we put all this stuff on the graph. We have a vertical asymptote at 0, horizontal asymptote at 1. We had a, minimum at negative 2, positive 3/4. No max The inflection point was at negative 3/7/9. Okay, so my graph starts off, we are decreasing until we get to -2. So my graph has to be falling. It is curved downward. So it's falling but curved downward. I may have to adjust my graph a little bit so I can actually show this. I think I'm going to make my 1 all the way up here. Just to kind of help illustrate something. So we're decreasing and curving downward. So it's just under that asymptote. Once we hit that inflection point, we are curving upward until we get to 0. And my graph also switches to increasing until we get to 0. So we're increasing and curving upward. Okay, now we're going to be continuing to curve upward, but my graph is going to decrease. So decreasing but curved upward would look like that. So that's my final graph. Last question is 18. Are we good on this? You guys aren't stopping me at all. Must be because I'm just so easy at explaining things. You have no questions left. I'm sure that's what it is. Can't help it if I'm perfect. Okay, suppose you were to make a rectangular box with a square base from 2 different materials. So we have this box. Okay, so here's my box. If the base is square, what do we know about these sides? Okay, so let's call them both X. And then we don't know anything about this, so let's call it Y. The material for the top and the 4 sides costs $1 per square foot. The material for the base is $2 per square foot. Find the dimensions of the box with the greatest possible volume. How do you find volume? X times y, so x squared y. Okay, that's what we want to maximize, so that's what we need to do the derivative of. But I have too many variables, so I need to get rid of one of them first. So that's where the cost comes into play. So the top costs $1 to make. So what's the area of the top of this box? X squared, and we're paying $1 for that. Okay, how much does the bottom cost? $2, and the area of that is also X squared. Okay, we have 4 sides. We pay $1 for each of them, and the area of each side length times width is XY. And that equals my total cost of $144. So we can solve for Y. So now I'm going to plug that in up here. Okay, so I could reduce an x. 144 divided by 4, so that would be a 36x minus 3/4 x cubed. That's what I need to maximize. So anytime I ask for a maximum or minimum, we do the derivative. 36 minus 9/4 x squared. And we want that to equal 0. So multiply by 4 and divide by 9. You would get x to equal positive or negative 4, but we know it could be a negative because it's the length. So x is 4. We need the dimensions of the box. height. To get the y, if we plug 4 in here, 4 squared is 16 times 3 is 48 over 16, so we get 96 over 16